Okay, starting 4.3, which is graphing equations using a slope-intercept format. And slopes, if we look at those, let me give you all four possibilities of slopes, because we only have four things that could possibly happen to them. And let me get four little graphs up here. And then we can see what takes place with each of these. So if we have four graphs, the different types of slopes, one is like so, and our line runs up at an angle. This one is considered to be a positive slope. And how we look at these is we look at them from left to right. And if they're climbing a hill or going uphill, that is considered to be a positive slope because it's going uphill and we're moving in that direction. If you have a negative slope goes downward, again working from left to right, so you're going downhill, which is negative. And so in these cases, this one would of course not have a negative involved with a positive, but the negative slope will have a negative sign out in front of it when we get finally talking about slopes. Then we had the two we just talked about. One was that straight up and down line, which is a vertical, and it has a undefined slope because it doesn't taper in any direction. It's straight up and down. And then the last one is the other one we talked about in the previous section, and that is a horizontal line. And it has a zero slope. Or, in other words, no x's in here. And this one has no y's. So that's what makes those two special, is that there's no x's and no y's in there. And so you have those type of things that are happening and taking place when we work on with our slopes. So that's all of our slopes. There isn't any other slopes. That's all that you possibly can have. And so then as you look at slopes, a slope is signified by an M, and you're probably saying an M. Why an M for slope? It's because graphing was designed by the French, and the word for slope must have started with an M at that case in that area. So therefore, I've got my slope, which is M. And the slope is the rise over the run. Now, what in the world does that mean? A rise means I go up. A run means I go over. So if I started here with one dot, and I went up 3 and over 4, I would have a rise and a run of 4. I can repeat that as many times as I would want, and what does come out of that every time I repeat my slope is I end up getting a straight line out of that rise and that run. So the rise is 3, so if this were my slope, 3 over 4, means I would go up 3 and I would go over 4, up 3 and over 4, and I'd end up getting that slope. Now because this has positive, notice it's a positive value, I ended up with a positive slope. Okay? If it were negative, if I had a negative 3 over 4, what would that mean? Well, if this were my point I started at, my rise says to go down 3 and over 4, down 3 over 4, down 3 over 4, and it again gives me locations in there, but in this case, because I went down with my slope, I end up having a negative slope in that case. So that's what makes the determining difference of whether that rise is positive or the rise is negative. So the rise is on top. So rise means I'm either going to go up or down. Go up if positive, and down if negative. And that's all over a run. And my run is always, on a run, you're going to move to the right for a run. So you're going to move to the right always. Don't go anywhere else but to the right when you do your rises and your runs. Now sometimes, if you remember back in algebra, they told you could go either way. But what happens is you guys get confused on which way you go and which ones. So if you just always do your rise going up or down based on whether it's positive or whether it's negative, and do your run to the right, you'll be okay. And you'll get your slopes to come out correctly. So if you had a graph and you were working on it, if you had one point location on your graph, you can end up coming up with what your graph is going to look like just from that one single point. So let's say we have this graph and they give you the point of 0, 3, and they give you a slope of 3/4. What would that mean? Well, that would mean I would start out at 0, 3, 1, 2, 3. Use my slope. My slope says go up 3, 1, 2, 3, and over 4, 1, 2, 3, 4, and plot it. And if I connect those two dots that I just created there, I get the graph of my line. And I didn't have any math involved in that at all, did I? All I had to do was use what I learned from 4.2 when or 4.1 when I located points, then used my rise in the top over my run in the bottom, and I was able to plot my graph of what that would happen to look like. And what was this point? Remember? What's its name? It's got a special name to it.
Be a y-intercept.
Yeah, y-intercept. Y-intercept. And it's a y-intercept because, again, it's got that 0 for the x, and y is equal to some value, so it's a y-intercept. So if I have a y-intercept and a slope, I can end up plotting a point. Or, if they just simply gave me a point, -2, 4, and they give me a slope of 1/2 for my slope, I can still graph that exactly as I just did the last one, because simply all I need to do is plot my one point. So my one point is a -2 up 4, and then use my rise and run after that point. Rise 1, run 2. Rise 1, run 2. And you can do it as many times as you want, and you will end up with the graph of that line just based on those two pieces of information. So it's pretty straightforward once you get your graphing done of what you have to do with those things to come up with them. And so that's what rises and runs help us out with, is this rise is on top, runs on the bottom, so it means go up 1 in this case, and over 2 from wherever you start with your point of where you happen to be at with that one. We did run up with a y-intercept in here, and it's at 1, 2, 3, 4, 5, so it's at 0, 5 would be my y-intercept if I had needed that for that problem. Okay, what do you think? Do that stuff? Again, plot your point, do your rise 1, run 2, and you will end up getting your answer. Now if that would have been a negative slope, let's say m would have equaled a -2/3, and my point were 2, -3, I would locate 2, -3. But in this case, I would go down 2/3 because it's a negative slope. Down 2/3. And then connect my dots. Whoops. Down 2/3. 1, 2, 3. Yep, I did it right. And if I connect those, I get the graph of my line. Now in Hawks, when you do this, your cursor is what you're going to move. You're going to start here, count down 2, count over 3, hit enter. Okay? Count down 2, over 3, hit enter. And that's how you're going to get those in there, so that you get your plotting done with your graph in there, in your hawks. Okay. Now, if you're given 2 points, and you want to find out what your graph is with 2 points, such as, let's say we're given the points of 2, 4, and 4, 8. And I want to know whether that's going to be a positive slope or a negative slope. So if I plot both of those points on my graph paper, this is one way of finding your slope. And we'll talk about an easier way. When I'm at 2, I'm up at 4. When I'm at 4, I am up at 8. And because it's going uphill, what does that tell me about my slope? Is it going to be positive? Yes. Will be positive because it's going uphill. And what you can do is, this was my dot and this was my dot. I can find out what my rise is by counting how far I went up to get to there. So I went 1, 2, 3, 4 spaces up. And how many did I count over? 1, 2. So my rise was 4. My run was 2. So what's my slope? Well, if I reduce it, 2 goes into 4 twice. 2 goes into 2 once. My slope is 2 over 1, or just plain 2 would end up being my slope. So if I plot points, I can find my slope. Or we can use the equation, or the, not equation, but the formula to find a slope. And that equation is m equals the change in y's, so y2 minus y1, over x2 minus x1, and the change in x's to be my other piece in this. So what would I do? Well, it's plotting in 2 points. So all you need to do is put your points in these locations. That's 1 point, that's the second point. So does it make a difference? I usually run them from this side back, so I get my order right. 8 over 4 minus, because it's always subtraction, 4 over 2. Then I don't mix them up and get them in the wrong location and in the wrong spots. So 8 minus 4 is 4. 4 minus 2 is 2. So it's exactly what we found when we did our points, or 2 over 1, or simply 2. If I put them backwards, would it still work? 4 over 2 minus 8 over 4. 4 minus 8 is a negative 4. 2 minus 4 is a negative 2. Still, a negative divided by negative is a positive, so I still end up with 2 over 1. So it doesn't make a difference which one goes in, but I need that formula to give me my values in there to come up with what I should have. So that's what I get with that one, is that I get my values that happen to be in there. So I got my formula that sits in there. So what about these 2 points? Negative 3, 4, and 7, 6. What's my slope? So if I plug them in, again, if I start at the back, I don't end up with getting into trouble on putting them in. 6 is my y, 7 is my x, 4 is my y, negative 3 is my x. So 6 minus 4 is 2. 7 minus a negative 3, what's that going to give you? So now all that math from chapter 1 is back. 10? Yeah? So really my slope is 1 to 5. Rise 1, run 5. So if I were going to plot that, I could do that. I could just plot one of these points and end up with all the rest of it just by doing that 1 point and coming up with my values based on my slope. So rise over run is what I happen to have in there for that one. How about this one? 2, negative 4, negative 6, negative 9. What's my slope? If I work that one out, what happens to it? Negative 9 over negative 6 minus minus negative 4 over 2. Negative 5 is the top. What's the bottom? Is it negative 8 or positive 8? Negative 8. Yep. Remember, with your subtraction, you change your sign and change the sign on the one after it. So negative 6 plus a negative 2 is a negative 8. So my slope is a positive 5/8. Yeah, for that one. Okay with that, do you think? Because it's going to ask you in there, it's going to say, here's your points, here's your 2 points that you happen to have, and find the slope that's connected with those, and coming up with that. The last piece in this part is taking a look at coming up with, well, first before I do that, I better give you the other point here. What if you had 3, 5 and 4, 5? What's my slope? I guess I better do another slope one. Kind of getting a little bit ahead of myself.
It would be a x.
So I have 5 over 4 minus minus 3 over, no, 5 over 3, sorry. So 5 minus 5 is 0, and 4 minus 3 is 1. So what's my slope? 0. Right? So this one, if you notice in your points, notice the y's are identical. So this is a y equals 5 because it's crossing always, if I plotted both of these, and if I plotted at 4, I'd be up at 5, I'd have a straight line or a horizontal line, so my slope would be 0. If your points are 5, 3 and 5, 5, what's that one's slope? It's going to be an undefined, because 5 over 5 minus minus 3 over 5. 5 minus 3 is 2, and 5 minus 5 is 0, but I can't have a denominator of 0, so this is undefined. Later on in the chapter we'll get into finding equations, and if we find equations, notice this one, your x's are the same, so it's going to be an x equals 5. Or it's going to be, if I plotted it, it would end up being a horizontal line. Not horizontal, a vertical, sorry. A vertical line going straight up and down. And so therefore we'd have a vertical piece in there. So be careful with these. If 0 comes out as a denominator, you're going to need to watch that one. Now the last piece that's in here is if you got an equation of y equals 4/5 x plus 2, this is what's considered to be in slope-intercept form. The reason being is it's in the format of y equals mx plus b. M we found was our slope. B in this case is our y-intercept. So if I get my equation, so I've solved for y, so in all of these solve for y, and you will have the slope and intercept. Slope is here, so m is 4/5. The intercept, or the y-intercept, and be careful in Hawks, because if you enter an intercept and you just put 2, it's going to tell you it's wrong. If you just put in a 2 in your certify, it's going to mark it wrong. You need to put 0, 2, because the 0, remember, is your x, and the 2 is your y in there, and so therefore I've got my 2 pieces that I need. So can I graph that? Yeah. All I gotta do is plot this piece, and it's going to ask you to do separate pieces in here in Hawks. So it'll first ask you what your slope is and what your intercept happens to be. Second problem that comes up will be graph your intercept. third piece that'll come up is use your rise and run to graph your line. So in this case, I would be at, let's see if I can get it all on here. 0, 2. So I'm up at 2. My intercept says rise 4, 1, 2, 3, 4, and run 5, 1, 2, 3, 4, 5. And connect them. Of course, Hawks will connect it on the computer itself. You won't have to connect it, and you are done graphing. So out of all the graphing we've done today, this one's probably the easiest one to do, because you don't have a whole lot of number plotting. You don't have to find a lot of things. The only thing you'd have to do is get y all by itself, and in solving for that. So we better do one of those where we're going to solve for y and see what happens. Find an example. Okay, 2y plus 6x equals 4. Not in the right format because it's not, we don't have y all by itself. So back in chapter 3 we did a lot of practicing and getting a letter by itself. So minus 6x then we need to get y alone, so I'm going to divide everybody by 2. So negative 6 divided by 2 is a negative 3. 4 divided by 2 is a plus 2. And so now I have it in what's called slope-intercept, because my slope is here and my intercept is here. So my m is a negative 3. Now notice it doesn't have a number under it, but I can make it to a fraction just by simply putting it over top of 1. And I can find my b, which is my intercept, which is 0, 2. And then I can end up taking those two and plotting them on my graph. And again, in Hawks, you will not have to draw your graph. All you will have to do is find your intercept. So that's 0, 2. Hit enter on your computer. Then my rise says to down 3, 1, 2, 3, and over 1. And as soon as you plot that point, Hawks will automatically put in your line. And so your line will run right straight through there, and that will be your line of that. Again, because the slope is negative, I get a negative slope with that one. Okay, what do you think? Maybe? Okay. Why don't we take, look at this guy